So for this one, write horizontal asymptotes, look at exponents beside it. Look at exponents. Alright, if the higher exponent is in the denominator, this means it's bottom heavy. And here's an example. Say if we have x squared plus 1 over x cubed minus 1. What's the biggest exponent? 3, right? And it's on what? Bottom. This one we call it bottom heavy. Anytime it's bottom heavy, you'll have an HA, horizontal asymptote, at y equals 0. So what would that look like? I'll draw it over here. Y equals 0 is the actual x-axis, and you would have a function approaching this horizontal line. Alright, if the bigger exponent is in the numerator, like x to the 4th over x squared, 4 is the bigger one, it's top heavy, which means you will have no horizontal asymptote. There won't be one on your graph. If it's the same degree, for example, 4x squared over 2x squared, they're evenly matched. You just look at the leading coefficient of the biggest exponent. So this leading coefficient is what? Over 2. So 4 divided by 2 is what? Good. So you have a HA at y equals 2. So bottom heavy, y equals 0. Top heavy, no HA. Evenly distributed, you divide their coefficients to find the HA. So for number 1, do I have an HA? Is it top heavy, bottom heavy, or neither? Neither. Good. So we divide their what? Yep. What are the leading coefficients? 1 and 2. So I have an HA at y equals 1/2. Good. Make sure you put y equals 1/2 because this represents a horizontal line. So that's where the actual line is going to be when you graph it. Alright, next one. Top heavy, bottom heavy, or neither? So I have no HAs. Good. Next one's top heavy, bottom heavy, or neither? So I have a HA at. Very good. That's it. Any questions about horizontal asymptote? Alright, flip it over. Now we're going to get into vertical asymptote. That's when it's approaching a vertical line, and holes. Sometimes rational functions have holes in your graph, and you'll see where. But on your graphing calculator, when we get to graphing it next or tomorrow, they won't show holes on your graph. Like when you graph it in your graphing calculator, you can easily see where there's a horizontal and vertical asymptote. So you can kind of cheat on that. You can just use your calculator. But holes you have to do by hand because your graphing calculator is so tiny it won't show it. Alright, so first step to finding VAs, vertical asymptotes, and holes, you have to factor the numerator and denominator and simplify. First step. So the top, when I factor it, will factor into what? 3. Very good. What will the bottom factor into? Almost. Very good. Alright, will anything cancel? No. So if nothing cancels, that means you have no holes in your graph. You only have holes when something cancels. So we can go ahead and put no holes. Alright, for vertical asymptote, that is when we were talking about when the bottom is equal to 0 right here. Vertical asymptote. So to find mine, I just set my bottom 2 factors equal to 0 to find your vertical asymptotes. So one vertical asymptote will be at what? If I set this equal to 0. Not y though. Vertical line means it's what? Good. X equals -9. You'll also have a VA at what? Very good. Alright, last thing is we are going to talk about HAs just so we don't forget. For HA, which is what we did on the last page, we look at the original. Is it top heavy, bottom heavy, or neither? Good. So where's my HA at? Very good. Questions about that? Alright, we'll do 2 more together. What's my first step? Factor. What do I factor the top into? Good. Bottom? 4 and what now? Very good. Will anything cancel? Yes. This means I have a what? Yes. Now a hole is a coordinate point. It's the same thing as a point on a graph, except there'll be an open circle like this. This is what a hole would look like. Just like that. It's a coordinate point. It's just a hole there. To find it, first of all, this is the x value that it's dealing with. If I set this equal to 0, I'd have what? 1. So the hole is at 1 for my x value. How do you think I find the y value? You're thinking x-intercept. I do plug in something. I plug in what? 1 for what? X. Good. So I'm plugging it into my x value right here. I'll have 3 on top. I know that. It's going to be 3 over what if I plug 1 in? Very good. So my hole is at 1 3/5. That coordinate point means there's going to be a hole right there in this graph. All right, let's talk about my VAs. VA is when I set what to 0? Set the, how do we find these? Set the denominator equal to 0. Good. What's my only denominator here? Yes. So when I set this equal to 0, I'll get, good. So I have a VA at x equals, very good. For my HA, I look at my original. Is it top heavy, bottom heavy, or neither? So I have a HA at, very good. There's my vertical asymptote, horizontal asymptote, and my hole. One more together. Questions so far? Alright. Tell me what the top will factor into. Very good. The bottom, can I factor it? Anything cancel? That means I have a, and let's find out where. What's my x value? Yeah, got to set this equal to 0, so I get what? Find my y value, I plug it in. So what is -2 minus 2? Good. Where's my VA at? There's not one. Good, because is there a denominator anymore? Nope, so I have no VA. Now look at the original. What about my HA? It's top heavy, so no HA. Very good. Alright, I want you to work on 7, 8, 9, and then 1 through 4. That's your homework. Just finding the horizontal, vertical, and asymptotes and holes. Or you can pack up. But while you're doing that, I want to show you what this looks like on a graph. Pick one of the ones we just did. Which one? 6. Actually, let's pick another one because I want to show you one with a VA or an HA. Okay. It won't show you on the graph, but I can do 5. That's fine. All right. So you would just plug it in just like regular y equals. Just make sure that your numerator's in parentheses and your denominator's in parentheses. Alright, it's kind of hard to see because this graph has got a table beside it, but see where there's a vertical asymptote right here where it's approaching this x value but not touching it? That's at -9, if you can't tell. And if you look over at your table, excuse me, not -9, -4. See where it says -4 error right here? That's how you can tell it's a VA on your calculator. Did we have a hole? Yeah, we had a hole at 1. So let me show you. In your table also, it'll say what? Error for 1, where our hole is. So you really do have to do it by hand to figure out if it's a hole or a vertical asymptote, or you can just look at 1 and see how there's no vertical asymptote at 1, x equals 1. We're going to get into graphing these tomorrow. I just wanted y'all to find discontinuity today. But 7, 8, 9, and when 1 through 4 is your homework, that's not due till Friday. Y'all can go ahead and pack up if you'd like. On your way out, turn in your 6-1 and 6-2 homework into this bin. It's going to be on this desk right here.